So then exercise B here, quite difficult exercise, but the thing is there's a hole in the top here on this Pantheon thing, and the sun comes through the roof here like this, and we want to find out how big this angle V here must be if the sun should hit the floor. And we see we have this angle here. The sun does not hit the floor. We need a bit more bigger angle here, maybe like this. And if I now draw the sun line here, oh, sorry, this is not a straight line, then I will hit the floor, right? Something like this, okay? Hope you see the picture. So, and that question is, how big must this angle be if you want to hit the floor? And the thing is that here we have a line, and this line is parallel to this line. So we have two parallel lines, and we have this line which is crossing these two parallel lines. So this means that this angle is the same as this angle. So we can find this angle here. And you really just need to make a sketch here and try and find out as much as possible. But actually, remember, this is the point A, the left of this oculus here, and this is the point B. But if you just look at this exercise, you will see that to find angle V, you can look at this triangle here. If I call this triangle here, that's the key, like this, okay? And let me call this point for R, for example, and let's call this point for T. So we will need to look at the triangle ART, okay? And we need to find some sides here. And if you look close at this here, if I now also mark P here and just draw this line down here, here we have Q on the figure, and we can go further down, and let's call this point for something. Let's call it C or whatever, like this. And if you look here, the radius, you have to see that QA or QB, whatever, that is the radius of this half circle here, the half square, right? And that is the same as this side. This is also 21.65, and it says that the height of the cylinder is the same as the radius of the half square here. So this is also 21.65, and this is 21.65. And now I need to find this side here, and this is of course 21.65. But I also need A, and down here, from A to down here, and that's the same as from P to Q. So I actually need PQ here. And that is not the radius, because P doesn't lie on the square here, almost, but not entirely. So I need to find PQ. And we have this triangle up here, AQP, and then PQ, according to 12, is the adjacent side, and we know the hypotenuse, 21.65. So we know that cosine of 12 degrees here is equals to the adjacent side, which is PQ, divided by the hypotenuse, which is 21.65. So we need to start here. And this I can solve on cos, just call PQ x. Then I will get an answer here. Cosine 12, remember degrees, is equals to x divided by 21.65. And I press this one, so we get 21.18. Let's go back to the figure here. So PQ, distance from Q and up to P, is 21.18, and that's the same as A and down to this line. So this side, I think I need another color here. Let's take a red one here. So this side here is 21.18, and this side here is 21.65. So this side here in the triangle, which I call AR, is 21.18 plus 21.65, which is 42.83. So now I have one side in this triangle I'm talking about here, and I also can find this side RT here because RT is this side here. Okay, let's go over here. I want to find this side here, but I know that this side is 21.65. And then I add this side here, and that is AP, radius of the oculus here, which I found in exercise A, which is 4.5. So this is 26.15, I guess. Yes, like this. So now we're getting here. This is 26.15. This side is 42.83, and it's a right angle triangle, and I want to find the angle V here. I know the opposite side, and I know the adjacent side, and I have to use tangents. I know the tangents of V is the opposite side, which is 42.83 divided by 26.15. And then this I can solve in cos. So I just call the angle for x degrees like this. So I will find angle V here, find the answer of the task here. Let's do this in cos. So we have tangents. No, cos won't work, of course. Tangents of x degrees is equals to 42.83 divided by 26.15, and then I just press solve here, and we get 58.6. That is the answer. Angle V here is 58.6 degrees. So this is this angle here. That's the angle here, which is the same as this angle here. So that's the answer on exercise B.